Hey everyone, I wanted to go over the quiz. So it says to find the derivative with respect to x. With respect to x means that x is your independent variable. So this phrase would always mean that you're finding dy over dx, right? This phrase again is derivative of y with respect to x. So with respect to would always be the denominator of this notation. So first example, we have 2x cubed plus we have x's and y's, and we need to use implicit differentiation. So just to recall, remember, e to the something, right? If y equals e to the something, then if this something is more than just x, we need chain rule. So y prime would be the derivative of this something times e to the something. So that being said, let's go back here. 2x cubed, well, there's just an x here, so this is 6x squared. Plus, well, now we have 2 times e to the 3y. So it's not just y, it's 3y, so we need chain rule. So derivative of 3y would be 3 times, we have 2, and e to the something is just e to the something. Since this is y, we need to write the dy over dx because we're taking the derivative with respect to x. So anytime you see a y, we need to add on that dy over dx equals, well, 2y. Derivative of 2y is 2, but since there's a y, again, we need dy over dx. And now we're finding dy over dx, so we need to isolate. So I'm going to bring all the terms with dy over dx to the left and the terms without on to the right. So I'll subtract 6x squared over there. Here we just have, well, 3 times 2 is 6, e to the 3y dy dx. I'm subtracting this 2 over, minus 2 dy over dx equals, and this 6x squared I'll subtract over to this side. So all the terms with dy over dx are to my left, the terms without are to my right. Next step is to factor so I can isolate dy over dx. And when I factor this out, I'm left with 6e to the 3y minus, I factored this out, 2. And my last step would be to divide that over. So dy over dx equals negative 6x squared all over 6e to the 3y minus 2. Question 2. Well, notice it's ln, and then there's parentheses of cosine, and then there's parentheses of some inside. So this is a chain rule because we're not multiplying ln to cosine, right? ln takes an input. When you have the function ln, it's ln of a number, or ln of x, or ln of some expression. This is a log, right? It's the natural log. We have an input to the natural log. So this is not a product. Even trig functions, cosine, you have to have cosine of something, right? It's cosine of x or cosine of x squared plus 1. But trig functions also have an input. If you had ln of x times cosine of x, where they each have their own input, this would be an example of a product. And then you would take the product rule. So be careful. Parentheses are usually a good indication that you're going to use chain rule. So in this case, we actually have a triple, right? Here's my innermost function. This is what's going into cosine. And then cosine, well, x squared plus 1 is going into cosine. And then ln, well, this whole thing in red is what's going into the natural log. Since it's a triple, remember, it's derivative of the inside. My peanut M&M is my peanut times derivative of the middle. That's the chocolate times derivative of the outside. So inside is this x squared plus 1. Well, that's just 2x. The middle, we have, so remember, cosine of something, if that something is more than x, well, then we take the derivative of that inside. Well, that's what the 2x is. But cosine of something becomes negative sine of that same something. So this is negative sine of x squared plus 1. There's the middle. And then we have ln. Remember, ln of x, ln of x, the derivative is 1 over x. But it's whatever's inside. In other words, ln of something equals 1 over that something. So ln of this whole inside becomes 1 over that whole inside. Whatever the input is. And now we can put this all together. So I have the negative, it looks nice to put the negative in front. Negative 2x sine of x squared plus 1 all over cosine of x squared plus 1. This next question was asking to find the limit. And here we have theta is our variable. Theta is usually an angle. And it says theta approaches 0. So limit at a number your goal is to plug in. But you know that's going to give you 0 in the denominator. And the inverse tan of theta, if you weren't sure, you know it's probably 0 or infinity. Can't plug it in, so let's use L'Hopital's rule. So we can take the, so remember, arctan is really just a fancy way of saying tan inverse 1. So this is what we're looking for the limit of. So we'll take the derivative of the numerator, tan inverse. And so that is 1 over, now instead of x, it's theta, so 1 plus theta squared, all over derivative of the bottom, well, 2 theta is just 2. So I think what might have tricked some of you here was you didn't realize theta was your variable. And so we're taking this derivative with respect to theta. Now we can go ahead and plug in 0 for theta. If I plug, so let's just write it, 1 over 1 plus 0 squared all over 2. Well, 1 plus 0 squared is just 1 over 1, which is just 1 over 2. Final answer.